Toyota is working on a groundbreaking new engine that it believes could completely revolutionize the automotive industry. While the world rapidly shifts toward electric vehicles, Toyota has made a surprising announcement that might just change everything. This new development suggests that EVs might not be the future after all. Instead, Toyota's new hybrid engine could be the game changer the industry's been waiting for. What if electric vehicles aren't the ultimate solution? What if a brand new engine is about to disrupt the entire industry for years to come? Toyota has been quietly playing the long game, perfecting something behind the scenes, while others focus on batteries and charging stations. Now they're finally ready to reveal what could be their most significant innovation yet. So what is it? Let's dive in. Toyota's legacy, from humble beginnings to automotive giant. Toyota's CEO recently made a bold claim that has sent shockwaves through the auto industry, stating that their new engine could completely overshadow the electric vehicle market. But before we uncover this groundbreaking innovation, let's take a step back and understand how Toyota became the powerhouse it is today. Toyota's journey to becoming an automotive leader is a story of innovation, resilience, and strategic vision. Founded in 1937 by Kiichiro Toyota, the company originally emerged from the Toyota Automatic Loom Works, a business started by his father, Sakichi Toyota. Sakichi was an inventor who transformed the textile industry with his creation of the world's first automatic loom in 1924. This invention not only improved efficiency, but also introduced the concept of jidoka, the idea that machines should stop automatically when problems occur. This philosophy would later become a key part of Toyota's manufacturing process. The shift from textiles to automobiles was sparked by Kiichiro's vision and the capital raised from selling the loom patent to a British company in 1929. Seeing the immense potential in the automotive sector, Kiichiro established an automotive division within his father's company, leading to the production of Toyota's first passenger car, the Model AA, in 1936. This marked the official birth of Toyota Motor Company in 1937. After World War II, Japan faced severe economic challenges, and like many other companies, Toyota struggled to survive. During this tough period, key figures at Toyota, including Taiichi Ohno and Eiji Toyota, sought innovative ways to improve efficiency and cut waste. This led to the creation of the Toyota Production System, TPS, a manufacturing method that focused on just-in-time production in jidoka, automation with a human touch. TPS also introduced the concept of Kaizen, or continuous improvement, encouraging every employee to actively contribute to identifying and eliminating inefficiencies. This culture of constant enhancement became deeply ingrained in Toyota's operations, driving improvements in both quality and productivity. Toyota's commitment to innovation was demonstrated with the introduction of key models that helped establish its global presence. The Toyota Crown, launched in 1955, was the company's first mass-produced passenger car, marking a significant milestone in building Toyota's reputation in the automotive market. Following this, the Toyota Corolla was introduced in 1966. Designed to meet a wide range of consumer needs, the Corolla became famous for its reliability and affordability. It quickly became one of the best-selling cars worldwide, symbolizing Toyota's dedication to quality and customer satisfaction. By the 1980s, Toyota had firmly established itself as a global automotive leader. The company's emphasis on reliability, efficiency, and continuous improvement resonated with consumers across the world. The principles embedded in the Toyota Production System not only improved manufacturing processes, but also nurtured a corporate culture focused on quality and innovation. This foundation enabled Toyota to navigate challenges, adapt to changing markets, and consistently produce vehicles that exceeded customer expectations. The evolution of Toyota's engines. Toyota's success didn't happen overnight. It was built on years of engineering breakthroughs, with its engines playing a pivotal role. From its early engines to the legendary power plants Toyota is known for today, the company's engine technology has evolved to meet the needs of drivers and the demands of modern engineering. In the 1930s, Toyota began its automotive journey with the development of the Type A engine. This 3.4-liter inline-six engine powered the Model AA, Toyota's first passenger car, marking a key moment in the company's history. After the success of the Type A, Toyota introduced the R-Series engines in the 1950s. Notably, the 2.0-liter 3R and 1.5-liter 2R engines became known for their durability and simplicity, powering models like the Toyota Crown and Land Cruiser. These engines were produced for decades, with multiple iterations and improvements, solidifying Toyota's reputation for reliability. As Toyota expanded globally, the demand for efficient, reliable engines grew. The company's continuous innovations helped them stay ahead of the curve, allowing them to introduce some of the most iconic engines in the automotive world, which have played a key role in Toyota's enduring success. The road ahead, a new game-changing engine. Now, after years of perfecting their technology, Toyota is unveiling what it believes could reshape the future of the automotive industry. As other manufacturers race toward electric vehicles, Toyota's new hybrid engine is a bold step that may challenge the status quo. Could this new development be the key to Toyota's next era of dominance? Only time will tell, but one thing is clear: Toyota's commitment to innovation is far from over. As demand for high-performance engines grew, Toyota developed several iconic power plants that have become legendary among enthusiasts and racers alike. Among the most celebrated engines in Toyota's history are the 1JZ and 2JZ, introduced in the early 1990s. The 1JZ, a 2.5-liter twin-turbocharged inline-six, made its debut in 1990. Known for its strong performance and smooth power delivery, it featured a robust cast-iron block and a high-revving nature. Producing around 280 horsepower, the 1JZ powered models like the Toyota Chaser Mark I and the Toyota Soarer, offering a blend of luxury and performance. In 1991, Toyota introduced the 2JZ, a 3.0-liter twin-turbocharged inline-six. This engine quickly gained worldwide acclaim for its strength and tuning potential. With a factory output of 280 horsepower, it powered the iconic Toyota Supra Mk4, among other models. The over-engineered design, including forged internals and an iron block, allowed tuners to push the engine to incredible limits, with some builds reaching over 1,000 horsepower. Its performance and durability have cemented its status as a legend in the automotive community. Another notable engine is the 4AGE, introduced in the early 1980s. This 1.6-liter inline-four became known for its versatility and performance. With a dual overhead cam and 16 valves, it produced between 112 and 130 horsepower, depending on the variant. Its high-revving nature and responsiveness made it a favorite among car enthusiasts. The 4AGE engine powered the Toyota AE86, a lightweight rear-wheel drive coupe that became famous in motorsports, particularly in drifting. The AE86's balanced handling and tunability earned it a dedicated following that continues to this day. Toyota also became known for producing reliable diesel engines, such as the 1HDT and 1KD-FTV. These engines helped build the Land Cruiser's reputation for durability and off-road capability. The 1HDT, introduced in the 1990s, is a 4.2-liter turbocharged inline-six diesel engine renowned for its strength and torque, making it ideal for the Land Cruiser 80 series. The 1KD-FTV, a 3.0-liter turbocharged inline-four diesel engine, replaced the 1HDT in the 2000s. It featured Toyota's D4D common rail direct injection system, offering better fuel efficiency and performance. This engine powered models like the Land Cruiser Prado and the Hilux, continuing Toyota's legacy of reliable diesel powertrains. As environmental concerns grew, Toyota shifted its focus towards developing engines that balance performance with efficiency. This led to innovations like VVTi and D4S fuel injection systems. VVTi, introduced in the late 1990s, allowed for continuous adjustment of camshaft timing, optimizing performance across different RPM ranges. It improved fuel efficiency, reduced emissions, and enhanced power delivery. Engines like the 1ZZ-FE and 2ZZ-GE, which featured VVTi, benefited from better throttle response and overall performance. The D4S system, introduced in the mid-2000s, combined direct and port fuel injection to optimize combustion. This dual injection system allowed for precise control of the air-fuel mixture, improving power delivery, fuel efficiency, and reducing emissions. Engines like the two GRFS EV6, which utilized D4S technology, offered a balance between performance and environmental responsibility. However, Toyota's true game changer came with hybrid technology, something that would set the company apart for decades. In December 1997, Toyota introduced the Prius to the Japanese market, marking a groundbreaking achievement in automotive technology. The Prius combined a 1.5-liter gasoline engine with an electric motor, creating a hybrid system that offered exceptional fuel efficiency and reduced emissions. At the time, the Prius achieved about twice the fuel efficiency of conventional gasoline-powered vehicles, marking a major leap in automotive design. The Prius was designed with advanced features to enhance its ecological performance. One of the key innovations was its regenerative braking system, which converted kinetic energy into electrical energy during braking and stored it in the battery for later use. This not only improved fuel efficiency, but also extended the lifespan of the braking system. Additionally, the Prius used an engine stop-start system that shut off the engine when the vehicle was stationary, further conserving fuel and reducing emissions. Central to the success of the Prius was Toyota's hybrid synergy drive (HSD) system. This full hybrid technology allowed the Prius to operate using just the gasoline engine, just the electric motor, or a combination of both, depending on driving conditions. The Prius's efficiency and pioneering hybrid system made it a landmark in the history of automotive innovation. The flexibility of Toyota's hybrid synergy drive (HSD) system gave drivers an optimal balance between performance and efficiency. The system included a power split device, a planetary gear set that managed how power from the engine and electric motor was distributed to the wheels. This setup allowed for a smooth transition between the two power sources, ensuring consistent acceleration and deceleration. Additionally, the HSD's design eliminated the need for a conventional transmission, reducing mechanical complexity and increasing reliability. A key component of the HSD system was the Prius's battery technology. The vehicle relied on a nickel-metal hydride battery pack, chosen for its balance of energy density, durability, and safety. This battery worked alongside the electric motor to provide extra power during acceleration and capture energy during braking, contributing to the Prius's overall efficiency. After its success in Japan, Toyota launched the Prius in global markets in 2000, where it quickly gained popularity, especially in regions with strict environmental regulations and fuel efficiency standards. Consumers were attracted not only to the Prius for its eco-friendly credentials, but also for its practicality and reliability. Toyota expanded its hybrid lineup to include models like the Camry Hybrid, Highlander Hybrid, and later the Urus Hybrid. This diversification allowed the company to reach a broader audience, securing its position as a global leader in hybrid vehicle sales. By 2013, Toyota had sold over 3 million Prius models worldwide. As the automotive industry started showing growing interest in fully electric vehicles, EVs, Toyota took a more cautious stance. The company expressed doubts about the immediate feasibility of EVs, raising concerns over battery technology, driving range, and the lack of charging infrastructure. Instead, Toyota focused on perfecting its hybrid technology, believing it offered a more practical solution for reducing emissions and fuel consumption. Toyota's strategy was grounded in the belief that hybrids struck the right balance between environmental sustainability and practicality. By combining the reliability of internal combustion engines with the efficiency of electric motors, hybrids addressed the early limitations of EV technology. This approach allowed Toyota to take advantage of existing infrastructure and consumer habits, making it easier for people to transition to greener transportation. While Toyota's dedication to hybrid technology earned both praise and criticism, it helped make fuel-efficient vehicles more accessible to the masses and reduced global automotive emissions. The Prius, in particular, became a symbol of environmental consciousness, attracting a diverse range of customers, from celebrities to everyday drivers seeking economical transportation. However, some critics argued that Toyota's focus on hybrids may have slowed the development and adoption of full EVs, especially as competitors heavily invested in electric vehicle technology. This raised questions about Toyota's long-term strategy and whether it might fall behind in the rapidly evolving EV market. Despite these concerns, Toyota continued to improve its hybrid systems, achieving significant advances in fuel efficiency, performance, and emissions reduction with each new generation. And while EVs are still the talk of the industry, Toyota's CEO recently made an unexpected announcement that could shake up the entire automotive market. But have you ever wondered why Toyota has been so resistant to fully electric vehicles? Toyota's cautious approach to EVs is, in part, a calculated gamble. Unlike many automakers that have aggressively pursued electric vehicles, Toyota has emphasized a multi-pathway strategy to achieve zero carbon emissions. This includes not only EVs, but also hybrids, hydrogen fuel cell vehicles, and other powertrain technologies. Toyota believes this diverse approach is more sustainable and practical for different markets and consumers, as relying solely on EVs may not be the most suitable solution for all regions. One of Toyota's main concerns about an all-electric future is the challenges related to battery production. Manufacturing lithium-ion batteries requires a lot of energy and involves the extraction of raw materials such as lithium, cobalt, and nickel. These processes can lead to environmental damage, including habitat destruction and pollution. Furthermore, the limited availability of these materials raises concerns about the long-term sustainability of mass battery production. Additionally, the high cost of EV batteries contributes to the overall price of electric vehicles, which can be a barrier for consumers, especially in emerging markets where affordability is key. Toyota argues that without significant advancements in battery technology and reductions in production costs, the mass adoption of EVs could be limited. Akio Toyoda, Toyota's chairman, has been outspoken about his skepticism regarding the rush toward EVs. He warns that focusing exclusively on electric vehicles could lead to unintended consequences, such as job losses in industries tied to traditional engine technologies. In October 2024, Toyota highlighted that Japan's automotive industry employs around 5.5 million people, many of whom are involved in sectors related to conventional vehicle technologies. Shifting entirely to EVs could risk the jobs of many people involved in engine-related work, not just manufacturers, but also a wide network of suppliers, buyers, and related businesses. Akio Toyoda has also raised concerns about the environmental benefits of EVs when considering their full life cycle, including manufacturing and energy production. He suggests that a more balanced approach, which combines hybrids and hydrogen fuel cells alongside EVs, may be a more sustainable and practical path forward. As part of this strategy, Toyota has heavily invested in hydrogen fuel cell technology. The company introduced the Mirai, one of the first mass-produced hydrogen fuel cell vehicles, to showcase its commitment to exploring alternative energy sources. Hydrogen fuel cells offer several benefits, such as quick refueling times and longer driving ranges compared to some electric vehicles. They also only emit water vapor, making them an environmentally friendly option. However, the infrastructure for hydrogen refueling is still lacking in many regions, which presents a significant challenge to widespread adoption. Toyota's cautious approach has faced criticism from industry analysts and environmental groups who argue that the company risks falling behind as global markets increasingly embrace electric vehicles. Competitors are expanding their EV offerings rapidly, and consumer demand is shifting towards more sustainable transportation options. Despite this, Toyota remains committed to its strategy, continuing to invest in hybrid technology and hydrogen fuel cells to offer a wide range of solutions that cater to diverse consumer needs and regional requirements. But what if Toyota has been playing the long game all along? What if they have something up their sleeve that could completely shake up the EV industry? The automotive industry is undergoing a massive transformation. The internal combustion engine, once central to mobility, is being phased out by governments and manufacturers in favor of electric vehicles. However, just as gasoline and diesel engines seem close to extinction, Toyota introduced a groundbreaking innovation. Reports and patent filings suggest that Toyota is developing a next-generation combustion engine that could revolutionize engine technology. In early 2024, leaked patents revealed that Toyota has created a water-cooled hydrogen combustion engine designed to address one of hydrogen power's biggest challenges, excessive heat. Unlike traditional gasoline engines, hydrogen combustion generates very high temperatures, which can lead to efficiency losses and durability issues. Toyota's new design tackles this problem by incorporating water injection valves into the intake ports of each cylinder. These valves precisely control the amount and timing of water injected into the engine, ensuring optimal cooling and significantly improving efficiency. The engine's electronic control unit monitors real-time data, adjusting the process dynamically to ensure smooth operation under various conditions. If successful, this could result in a hydrogen-powered engine that offers all the benefits of traditional combustion engines: quick refueling, long range, and high performance, without the carbon emissions. But Toyota isn't stopping there. While the world debates whether electric vehicles are the ultimate solution, the company has been quietly advancing battery technology. One of the most exciting developments is Toyota's work on solid-state batteries, a technology that could transform the EV landscape. Unlike conventional lithium-ion batteries, which use liquid electrolytes, solid-state batteries replace these with a solid material. This simple change leads to significant benefits. Solid-state batteries can store more energy in a smaller space, allowing vehicles to travel longer distances on a single charge. They're also much safer, as they eliminate the risks of leaks and fires associated with liquid-based batteries. Perhaps most importantly, they can charge at unprecedented speeds. Toyota claims their solid-state batteries could be fully charged in just 10 minutes, solving one of the biggest drawbacks of current EV technology. In September 2024, Toyota's plan for next-generation battery production received approval from Japan's Ministry of Economy, Trade and Industry. Production is set to begin in 2026 with an annual output goal of 9 gigawatt-hours. If these projections hold true, Toyota could surpass its competitors in the battery race, delivering a product that makes current lithium-ion EVs seem outdated. The most surprising part is that Toyota's solid-state battery development may not only be for electric cars. There's growing speculation that the company might integrate this technology into its hydrogen combustion engines, creating a new category of ultra-efficient hybrid vehicles. The potential implications of Toyota's next-generation engine technology are enormous. If hydrogen combustion engines can be perfected, they could eliminate one of the biggest drawbacks of electric vehicles: charging time. Instead of waiting 30 minutes or more for an EV to charge, drivers could refuel their hydrogen-powered cars in just a few minutes, just like they do with gasoline. The driving range could also be much longer than current EVs, making long-distance travel more practical. And from an environmental perspective, hydrogen combustion engines produce only water vapor, meaning zero carbon emissions. But even beyond that, there's a crucial factor that isn't being talked about enough: the environmental cost of EV battery production. Mining the raw materials needed for lithium-ion batteries, such as lithium, cobalt, and nickel, is an energy-intensive and environmentally damaging process. Hydrogen and biofuel-powered engines could offer an alternative that bypasses these concerns entirely. With all these advancements, the automotive world is buzzing with speculation. Is Toyota preparing to make traditional EVs obsolete before they even hit mass adoption? Industry experts are divided. Some believe Toyota's multi-pathway strategy, developing hydrogen combustion, hybrids, and solid-state EVs simultaneously, could make the company a dominant force in the next generation of vehicles. Others argue that hydrogen infrastructure is still too underdeveloped to compete with established EV charging networks, and Toyota may be betting on technology that's too far behind to catch up. But one thing is clear: while other manufacturers are scrambling to go fully electric, Toyota is proving that there's more than one way to achieve a carbon-neutral future. Their latest innovation could shake up the entire EV market and challenge the assumption that electric vehicles are the only solution. And now the wait is over. In fact, Toyota's CEO just made a bold statement. "Our new engine will destroy the entire EV industry. I've made my decision. We are putting it on the market by the end of 2026. But what makes this engine so special? According to insiders, this next-generation powertrain is unlike anything currently available. Toyota has reportedly developed an ultra-efficient hydrogen combustion engine that significantly outperforms existing battery electric and hybrid technologies. Unlike traditional hydrogen fuel cell vehicles, which convert hydrogen into electricity, this engine uses hydrogen directly as a combustion fuel. The result is a system that maintains the power and refueling speed of a gasoline engine, while producing nearly zero emissions. Toyota's engineers have integrated advanced cooling and injection technologies to solve the high-temperature issues typically associated with hydrogen combustion. By utilizing a precise water injection system and proprietary ignition technology, this engine not only eliminates harmful carbon emissions, but also achieves efficiency levels that were once thought impossible for internal combustion engines. Industry analysts suggest that Toyota's breakthrough could reshape the automotive landscape. With concerns over EV battery production, resource mining, and charging infrastructure still unresolved, a hydrogen-powered alternative offers a compelling solution. While hydrogen refueling infrastructure is still in development, it has the potential to expand more rapidly than mass EV charging networks, making it a viable long-term competitor to battery electric vehicles. But here's the real kicker. The implications of this technology go beyond passenger cars. Toyota is reportedly in discussions with major trucking and heavy machinery manufacturers to implement the engine in commercial fleets, where long refueling times and battery weight present significant challenges. If successful, this engine could disrupt industries that have been slow to fully adopt electrification due to logistical hurdles. Despite skepticism from EV proponents, Toyota remains confident that its strategy will pay off. The company has historically taken a long-term approach, prioritizing sustainable yet practical innovations over following industry trends. While many automakers have placed all their bets on battery electric vehicles, Toyota's diversified strategy allows them to hedge against unexpected market shifts and technological developments. With the official launch set for the end of 2026, Toyota's bold gamble could either redefine the future of transportation or become one of the biggest risks in automotive history. What do you think? Let us know in the comments.